Hi guys, Mrs. Lyons here. Today we are going to talk about mole conversions. Okay, so we've talked about how we do conversions between things like feet and inches and centimeters and meters. Now we're going to get into how this applies in chemistry. So the thing that helps you in chemistry to do these types of conversions is what I call the mole map. And from the mole map, we can derive all of our equality statements. Okay, so mole conversions are no different than all of the other types of conversions we've done. You just have to know what your conversion factors are, what your equality statements are. So the mole map helps us to get there. And right now, our mole map has 3 parts. In our next unit, we're going to add another entire 3 more steps to our mole map. But right now, when we talk about moles and converting moles to molecules or moles to grams, we're always talking about the same substance. So substance A. We don't have any other substance. We're not talking about things reacting yet. So we're always going to be talking about compound A. If compound A is water or carbon dioxide or sodium chloride or some other compound. Okay, now you'll see from my mole map that I've got some arrows. These arrows show what I can convert between. Okay, so I can convert between molecules, atoms, and formula units. That's one thing I can convert to moles. And in order to do that, I have to know that my equality statement, I'm going to abbreviate ES, equality statement, is the number of molecules in 1 mole. We know that there are 6.02 times 10 to the 23rd atoms or molecules or formula units is equal to 1 mole. Okay, this is, remember, this is called Avogadro's number. Alright, so if I want to go between molecules, atoms, or formula units to moles, I know that 1 mole is equal to 6.02 times 10 to the 23rd of those things. Alright, the other possibility is I might want to convert from moles to grams. If I want to convert from moles to grams, the thing that I have to know for my equality statement is that 1 mole is equal to the molar mass of substance A. So 1 mole of A is equal to the molar mass of substance A. Remember that we get the molar mass from by looking at the periodic table and adding up the masses of all of the elements. Okay? So our mole map gives us our equality statements. So let's just jump right into some examples. So example 1, how many grams is 43.6 moles of carbon dioxide? So I'm going to go through all the steps of this. If you get really good and don't write down the steps, you're given an unknown. I'm not going to take points off as long as you show your entire truth table. But if you're struggling with this, it's a really good habit to write all of these things down. So, my given, again, always the number. So in this case, 43.6 moles of CO2. My unknown is what I'm asking a question about. So how many grams of CO2? And then I need an equality statement. So I want to look back. I need to go between grams and moles. I want to look back at my mole map. When I'm going between moles and grams, I use the fact that 1 mole is equal to the molar mass. So my equality statement is 1 mole equals the molar mass. And we know that molar mass is in grams per mole, and in grams. Okay, so I have to figure out the molar mass of CO2 before I can do my problem. So I've got to look. I've got carbon dioxide. So I've got one carbon atom. And if you look at your periodic table, a carbon atom has a mass of 12.01. Then I've got two oxygen atoms. Oxygen atoms have a mass of 16 apiece. So I've got 12.01 plus 2 times 16 is 32. So that is 44.01 grams. So now I have my molar mass of carbon dioxide. So now I can set up my truth table. Truth tables are just like they were with regular conversions. We write down what is given first, 43.6 moles over 1. And then remember, just like in the past, our whole truth table is guided by taking these units, bringing them down here. Okay, so in this case, I have moles on top, moles on the bottom. If I look at my equality statement, 1 mole is equal to 44.01 grams. Alright, so let's do that math. Remember, I'm going to multiply across the top, so that means that I have to take 43.6 times 44.01. If I plug that into my calculator, I get 1,918.836. I'm going to round that to 2 places after the decimal. So my answer is going to be 1,918.84, and I've got grams of carbon dioxide. Okay, so that's how we would do that type of a problem. Let's jump into another problem. This one says how many moles is 8.93 times 10 to the 25th molecules of sodium chloride. So I'm going to go through my steps. I'm going to write down what is my given. My given is 8.93 times 10 to the 25th molecules. And I'm going to write that all the way out. I know it's a pain, but I don't want to get it confused with moles. So that's my given. My unknown, what's my unknown? It's the thing that's being asked for. How many moles? So my unknown is moles of NaCl. So what is my equality statement? My equality statement has to be something that is moles, how many moles equals how many molecules. So I'm going to jump back here to my mole map. If I look at my mole map, here's molecules, here's moles. I need to know that 6.02 times 10 to the 23rd molecules is equal to 1 mole. So let's go write that down. My equality statement is 6.02 times 10 to the 23rd molecules equals 1 mole. Alright, so now I'm going to set up my truth table. And my truth table, I'm going to start with my given, 8.93 times 10 to the 25th molecules. Alright, remember our units are going to guide us. So since we have molecules on top here, we need molecules to go down here. So my units on the bottom are going to be molecules. And let's look at my equality statement. That means I have 6.02 times 10 to the 23rd molecules is equal to 1 mole. So if I plug that into my calculator, I'm going to divide. I'm going to take 8.93 times 10. No, to figure out how to do this on my calculator. 8.93 So we're going to do 8.93 times 10 to the 25th divided by 6.02 times 10 to the 23rd. I didn't bring my calculator with me. Hold on, I'm going to pause. Okay, so I solved my calculator issues. If I take 8.9 times 10 to the 25th, divide it by 6.02 times 10 to the 23rd, I am going to get 148.3388704319. Whole bunch of decimal places. Remember, we're going to round to 2 places, so I'm going to get 148.338. So I'm going to round that to 34, and this is moles of NaCl. Okay, now let's look at another problem. Okay, this problem says how many grams is 4.93 times 10 to the 24th molecules of calcium chloride. Okay, so first of all, my given is 4.93 times 10 to the 24th molecules. My unknown is grams. Okay, so now if I look back at my mole map, take a look what this means. We've got molecules, we're going all the way to grams. So we're going to have to use 2 equality statements in this problem. So this is a 2-step mole conversion. Okay, so we want to go from molecules to grams. So we're going to have 2 equality statements. Our first equality statement is going to tell us that we have 6.02 times 10 to the 23rd molecules is equal to 1 mole. Our second equality statement tells us that 1 mole is equal to the molar mass in grams of calcium chloride. So I need to add up. I've got 1 calcium, which is 40.08, and I've got 2 chlorines, which are 35.45 each. So if I do the math on that, what do I come up with? I get 40.08 plus 35.45 times 2 gives me a molar mass of 110.98. So that's my mass of 1 mole. So now I have my 2 equality statements. I'm going to set up a truth table. And now, remember, since I have 2 equality statements, I have to have 2 parts in my truth table. I'm going to put 4.93 times 10 to the 24th molecules here to begin with. Okay, now remember, our units dictate here. So let's figure out what we do with our units before we plug in any numbers. So molecules is going to come down here. So molecules goes here. If I look at my equality statement, 6.02 times 10 to the 23rd molecules equals 1 mole. So I'm going to do that. 6.02 times 10 to the 23rd molecules equals 1 mole. Again, to figure out what units go down, I look, moles here, so therefore moles have to go here. In my second step, my second equality statement says 1 mole is equal to 110.98 grams. So now I can do my math. And notice on this one, we start out with 4.93 times 10 to the 24th, and we have to divide it by 6.02 times 10 to the 23rd, and then we have to multiply that number by 110.98 to get our final answer. When we plug this all into our calculator, we're going to get 908.856, so I'm going to round that to 0.86. Our units are going to be grams of calcium chloride. Okay, so that's an example of a two-step problem. So hopefully we've gone through 3 different types of problems. This is just for reference. We're going to practice these in class, but if you get stuck, come back, take a look at these, especially this two-step problem. And hopefully this helps. I will see you soon.